3, 2, 1.
Good morning, Dr. Lee. Our group member has Teck, Chong Han Zhe, and Lionel, Javier, Jospin. So today we are going to present about the sensor and its application in the working principle of the sensor. So first is the reed switch. Reed switch comes in two varieties called normally open and normally closed. The normally open reed switch is a when a magnet bring up to the reed switch, the entire switch equity becomes a part of a magnetic circuit. The two contacts of the reed switch become opposite magnetic poles. No matter which end of the magnet approach, the contact will polarize in opposite way and attack another. So for normally closed, the two contacts are normally snapped together, and when you bring out a magnet to the switch, these are called normally closed. Take a normally open switch and fix a magnet permanent to its class. The entire unit become normally closed reed switch. Bring a second magnet to the reed switch with a magnetic field of opposite polarity to that the first magnet. This new field cancel out the field of the first magnet. It now become a normally open reed switch. So for its application, we can found the reed switch can be in alarm system, safety, and automotive. The second sensor is photoelectric sensor. Photoelectric sensor use light as a medium. It captures the change in light depending on the object detection. The detection depends on the different quantity of light that enter the sensor. The light will be converted to electrical quantity depends on its application. So for the type of photoelectric sensor, we can see here the first photoelectric sensor is the receiver and the transmitter are in the same component. So for the 3B model photoelectric sensor, the transmitter and the receiver are at the different places. And for retroreflective model, the transmitter and receiver are at the same position, but the light goes through the target and reflected back reflect by the reflector. So the application of the photoelectric sensor are automotive, material handling, machine engineering, food and beverage, and the last one is door gates and elevator. So I will move the third sensor to my rest of the teammate.
Okay, my name is Lionel, Javier, and I will talk about inductive proximity sensor. So inductive proximity sensor is used for non-contact detection of metallic object. So the coil and oscillator, it creates an electromagnetic field in the closed surroundings of the sensing surface. So the metallic object causes the dampening of the oscillator amplitude. So the changes in oscillation is identified by the threshold circuit that changes the output of the circuit. The operating distance of the sensor is based on the nature of the material. So if we look at here, so this is the table where different metal producer is required different operating distance, and this is an example of the proximity switch. So application of inductive proximity sensors are the following. So we have oil and gas industry, which the sensor provide durable and reliable solution for measuring variables on offshore rigs, as inductive sensors are able to withstand harsh sea condition and are not affected by contamination, for example dirt, oil and grease. So they are also used in beveraging process, where inductive sensors are rugged and require low readjustment to achieve high product quality, and it also can produce a smooth production chain. So the third is traffic light. So inductive sensor does not require physical contact to sense the the presence of car. So go next. So the next is optical proximity sensor. So this is commonly known as light beam sensor of true beam type or retroreflective type. So this includes a light source and a sensor that detects the light. So the light source generates light of a frequency that the light sensor is able to detect that are not generated by other sources. So for example, infrared light. So the light sensor circuit is designed so that the light that is not pulsing at the fixed frequency will be rejected. So this the light sensor is typically a semiconductor device such as a photodiode that generates small current when light energy strikes, or a phototransistor or photodarlington that allows current flow when the light strikes. So the control circuit is used to control the output circuit at a certain level. So this is an example of the photo light. So the top one is the light through beam, and the bottom is retroreflective sensor. So next, so there are applications for optical proximity sensor are the following. So it is used to signal the presence of an object that blocks light. So objects that are opaque. Example, it detects whether the bottles are filled or not based on the amounts of light that passes through a bottle. This is used in bottling industry. So the next one is reflective sensors are also used to recognize targets within a limited range. So I will pass the next slide to my fellow teammate.
So my name is Teck. So I'm going to talk about the capacitive proximity sensors. Capacitive proximity sensors is a device that can detect an object without contact with it. The device applies the dielectric capacitance principle. So the target object can be either non-metallic or metallic materials. So this is the symbol of proximity sensors. And then this is the picture of example of capacitive proximity sensor. So next, principle of working of capacity sensor. The capacitive proximity sensor has 4 basic elements: dielectric plate, oscillator circuit, threshold detector circuit, output circuit, and the plate inside the sensor act as one plate of the capacitor, and the target act as another plate, and the A act as the dielectric between the plates. When a target object is placed at a preset distance from the plate of the sensor, the oscillator circuit begins the oscillation. When the capacitance reach the threshold point, the threshold detector circuit will trigger the output circuit. Pause.
Action.
So the output circuit will switch on or switch off the circuit depends on the sensor whether it is functioning as normally closed or normally open. So next, this is the picture showing the principle of working. When the target reach closely to the proximity sensors, the bulb will light up. Next, application of the capacitive proximity sensor. The capacitive proximity sensor are usually applied in industry sector. For example, liquid level detection, bulk material level control, and process control. So next, this is the working of liquid level detection. So when the water level increase and reach the capacitive proximity sensor, the sensor will light up, indicate the water level is high. So this is the example of process control. The capacitive proximity sensor will detect the presence of the object in the box. The advantage of the sensor: low cost, good stability, able to detect metallic and non-metallic materials, high speed and effective. And next disadvantage: it might be affected by temperature and humidity. Sometimes it could be triggered by dust and moisture. It is sensitive to noise and difficult in designing. It is not accurate as compared to inductive proximity sensor. So that's all. Thank you.